Arrow means what? Direction, right? So it's a vector, right? This is the velocity. This here, the V with a bar, is the average speed.
So if we're calculating the average speed on the next formula that you just started, it shouldn't be a vector on top, correct?
Yeah, this is a bar. Sorry. It's a bar. Is that okay? Now, the average velocity, I'm going to put A, V here, is going to be the displacement now. The displacement, is a vector divided by my time, okay? That's different. So if I have my initial position here, my final position here, I have this displacement vector, R vector. Now, that's different than if I count all this length here, that would be the average speed, because this is a different trajectory right there, right? The velocity deals with just the displacement. The average speed takes all the distance traveled, all right? So displacement is directly proportional to time. So this is directly proportional to time. When I say that, do you understand what I mean by direct proportion to time? So I'm here right now at time 0, right? And then I start moving. 1 second, 2 seconds. So this is the displacement. If I move another one, another second, 2 seconds, this is displacement. So the displacement depends on time, right? If I say it takes 6 seconds, it's going to be larger displacement than if I say it's just 1 second. Okay? Now, if the velocity is changing, right? If the velocity is changing, this is a constant velocity, right? So it's proportional to time. But if velocity is changing with time, then what happens to the displacement? There are two situations. I'm going to repeat. Okay? One is I'm going at constant speed. And I said the displacement is proportional to time once, because the speed is constant, right? 2 seconds, I have 2 steps, right? 4 seconds, I have 4 steps, right? So this displacement is proportional to time, and my speed is constant. Now, if the speed is also changing with time, then the displacement is changing by the square of the time. Okay? And that came up with the second experiment that you guys did. On the second experiment, we had the distance and time, and now this is not a straight line anymore, right? This is not the straight line anymore. And what's happening here? For every unit of time, there is a different rate of change, right? This distance here, per unit of time, is increasing. It's not constant. Before I had a straight line, And for each unit of time, I had a constant rate here. And there was a constant rate. The speed was constant, right? How fast I'm moving here is constant with time. But here, the speed is increasing. At this moment, the speed is one value. Here it's going to be another value, right? Like this is 1, 2, 3, let's say 4, and this is changing with the square of time. So the first one is 1. The second is going to be what? 4. The third is going to be what? 9, right? And then the other one is going to be 16. And then 25, right? So, what is the difference between 4 and 1?
3.
Difference between 9 and 4?
5.
Between 16 and 9?
7.
And here, 9. So, you see that this here now is changing at a constant pace, right? So let's see what that means now. Now the change here is changing at a constant pace. So if I graph the speed now and time, I'm going to see this is a straight line, okay? And here the slope is going to be and that is called the acceleration, right? How fast is the speed changing, right? That is the acceleration. And the acceleration is constant, right? The rate of change here is 2, 2, 2. So this is now, this is constant. This is increasing gradually with time. And this here now is constant. So, if I say a particle is accelerating at 10 meters per second, this particle is accelerating at the 10 meters per second. After 5 seconds, how fast it will be moving? How faster will be moving?
Multiplied by 5.
Huh? Who said that? 50. Will be 50 meters per second faster. Do you guys see that? So the acceleration, right, is how fast per second is increasing my speed, right? So if, let's say I have a speed of 5 meters per second right now. But every second is adding another 5, right? So every second I add 10 meters per second. Right? If 5 plus 10 is going to be 15. 1 second later, my speed is already 15 meters per second. The next second is going to be
20.
25. Because I add by 10 meters. Every second, the speed is increasing by 10 meters. Is that okay? So, so from here, let's come up with so the same way we had before, we had now this formula. A is going to be V0, and T0 is 0. So from here I get the same way I had for distance. Now I write V is going to be V0 plus AT, right? That is my second formula that I can come up with. And then I have here that V bar is going to be V0 plus V divided by 2. And then what I'm going to do is I'm going to plug this formula here right now. So this is not, this is bar, means the average. So V average is going to be V0 plus AT divided by 2. Okay? Now I add these two guys, and I have V bar equals 2V0 plus AT. This is divided by 2, this by 2, this is going to cancel, so I have V bar equals V0 plus AT divided by 2. All right? And what do I do now? Well, V bar is going to be X minus X0 divided by T equals to V0 plus AT divided by 2. I just substitute this formula from the one we already had. And now what do? I want to solve it for X. I multiply both sides with T. So I want to have X as a function of T equals to X0 plus V0T, AT squared divided by 2. So that is our next equation. So now, if I want to solve it for T, I need to know how to solve quadratic equations, right? Because this is going to be a quadratic equation. Remember, this here is parabola. You guys need to remember that y ax squared plus bx plus c. How do you calculate that when x is 0? How do you calculate that? X is equal to negative b plus or minus square root of b squared plus 4ac divided by 2a. This is another formula that you guys need to have it. Do you guys remember what this is? Parabola, right? So, what is a parabola? So, it could be something like this, right? Let's say I have a parabola that goes like that. This is y equals ax plus b plus c. So this is the equation of the parabola. The parabola is something that is like a U shape, goes that way. When this number here is negative, instead of a minimum, we have a maximum. But when I make y equals 0, what does that mean? When I find the values of x for y equals 0, what does that mean?
Find the intercepts.
Find the x-intercepts, right? When y is 0. So you have to pay attention. In physics, sometimes you're going to find, if you're calculating the time, you're going to find here maybe a negative value and a positive value. You have to select the one that makes sense. It doesn't make sense to get a negative value here. All right? So, so I think I'm gonna stop here now because, it's getting too late. So let's stop that meeting. Hopefully it came out good so I can post it.